experimenters, I'm Seth DeWall. The man behind the camera with the excellent handwriting is Usain Bolt. This is the incline plane experiment, parts 1 and 2. What a perfect way to start this experiment, and with a testimonial from a student who's done it. Here you go, read this.
Okay. Hi. I'm a 181 physics student. I just want to say this is my favorite experiment. I really, really, really love it.
Indeed. Excellent. Thank you very much for that. All right. So, let's take a look at what's going on here. Ultimately, we want to find the acceleration due to gravity and the acceleration due to friction on the inclined plane. So let's see what we have here. Well, what's going to happen is a glider is going to go down the inclined plane, recoil, and then go up. So let's find the expression for acceleration for both. Let's see here. Well, when it goes down the inclined plane, the gravity, acceleration due to gravity is that way, and then the acceleration due to friction opposes the motion in the other direction. Okay, that's good. So this is AG minus AF. Okay, all right, nice. All right, looking at the other direction, let's see here. Now it's going up, so this means that AG is going this way, and now AF changes direction because it wants to oppose the motion. So that's AF, giving us AG plus AF. Okay. Then with some algebra, you combine these into these. AG is 1/2 of A up plus A down. AF is 1/2 of A up minus A down. All right. So now, let's not waste any time. Let's go straight to the inclined plane and get some data. Here is our glider. Notice it rests on the inclined plane. And now I'm going to turn on a bed of air underneath it. That will give us an approximately frictionless surface, much like in air hockey. So I turn on the air, and there it goes, whoosh, down the incline. So let's get a closer look at this inclined plane, this glider, and let's take our first measurement. Notice this dot here is always facing you. And the first piece of data we need is the length of the glider, capital L. So we just match up the glider to the conveniently attached ruler. So let's see, I match up this side with 20, and then 20 to 34, 14.03 is what I get for the length of the glider. Okay, so now let's look at this trajectory. We'll release it from the top of the incline, and it will bounce off the bumper and then go back up. And look, now come take a closer look at what it has passed. It's passed two photo gates. In other words, there's a laser between here, and when it goes into the photo gate, it interrupts the laser and it sends a signal to the oscilloscope. And then when it leaves, that sends another signal, and when it goes to the bottom photo gate, it interrupts the laser, sends a signal to the oscilloscope, and when it leaves, it goes back, sends another signal to the oscilloscope, and then so on. When it bounces, it'll be the same thing. Interrupt and leave, interrupt and leave. Okay, so now, let's get a good look. At what this looks like here. Before we begin, on every setup, there will be directions on how to recall the setting you need to do each run. So, let's see here. So, to reset this, I push save and recall. And then, let's see here, setup 2, when I push recall, and then I need cursor. And then each run is started and stopped with a button run stop in the upper right-hand corner. Just like this. So just watch this for a second. Just watch this for a second. I'm going to take the glider and I'm going to interrupt the top photo gate, and we can see how it dips on the top line here. So in other words, non-interrupted, interrupted, non-interrupted, interrupted, non-interrupted. All right, and the same thing on the bottom. The bottom photo gate is represented by the bottom line, interrupted, out, in, out, etc. Okay, so now I'm going to start a run. So now I stop, and then I'm going to start as soon as it goes into the first glider, the first laser gate. Good. There it is. That's our first run. Now I turn up the air. Now, truthfully, it will take practice to get that. You want to get each of these 4 dips on the screen. It will take practice. You'll get it. You'll get it eventually. Now we want to read the times off of each of these lines. To do that, we use the time knob right here, and we want to switch it to where we read 100 milliseconds here. See, it's 500 milliseconds. We want 100. So I turn the knob. Let's see. Not quite. There it is, 100 milliseconds. And then I'm going to use the position knob here, the position knob, and I'm going to move the cursor. See this cursor on the left-hand side, this dotted line down there? I'm going to move that to where it's flush with where it interrupts the first photo gate. Right, almost there, right, I went a little past, right there. Okay, so now the cursor is flush with the first line of where the glider interrupts the first photo gate. And then I read that time in the bottom right-hand corner. Let's see, 444 milliseconds, 444.0 milliseconds. Okay, great. And then I slide the graph over to match the cursor again for T2. That was T1, now I'm looking for T2, 772.0 milliseconds. And then I just go down. I go down to where it interrupts the bottom photo gate, match the cursor up. That's T3, 1.616 seconds. Be careful of your units. We just switched to seconds, so make sure that you're consistent. And then T4 is the next line, and then so on. The next one is T5, then T6, then T7, and then T8, and that's our data for one run. That's our data for one run. So then you follow the directions to save recall, put it back to normal, turn the air back on, and then you get 4 more runs after that for 5 runs total. That's the data. Let's see what we do with it.